Have you ever wondered what keeps the stars burning for billions of years, shining across the universe with incredible heat and brilliance? Imagine if we could harness that same energy here on Earth. It's called nuclear fusion. And if we can master it, we could unlock nearly limitless energy, changing the way we power our world forever. At its core, nuclear fusion is the process that powers stars. Deep inside the sun, immense pressure and heat force hydrogen atoms to collide and merge into a new element, helium. When this happens, a tiny bit of mass from the hydrogen atoms is lost, but it doesn't just disappear. Instead, it transforms into a tremendous amount of energy, following Albert Einstein's famous equation, E equals mc squared, which shows that even a small amount of mass can release an enormous amount of energy. This reaction releases heat and light that travel across space, making life on Earth possible. For nuclear fusion to occur, atoms must be pushed together with extreme force. This is not easy, because atomic nuclei are positively charged and naturally repel each other, like two magnets with the same pole facing each other. In the Sun, gravity provides the pressure needed to overcome this repulsion. But here on Earth, scientists must recreate these extreme conditions using advanced technology. The most promising way to do this is by heating hydrogen gas to over 100 million degrees Celsius, which is much hotter than the core of the Sun. At these temperatures, hydrogen atoms move so fast that they can slam into each other and fuse. When this happens, energy is released, just like in the Sun. One of the biggest challenges in nuclear fusion research is containing this superheated gas, which becomes a state of matter called plasma. Plasma is different from regular gases because its atoms are stripped of their electrons, making it electrically charged and highly reactive. Plasma is incredibly difficult to control because it is so hot that it would instantly melt any container. To solve this, scientists use powerful magnetic fields to hold the plasma in place without it touching anything. This is done in devices like the tokamak, a giant ring-shaped machine that uses magnetic fields to keep the plasma stable while fusion reactions take place. Unlike nuclear fission, which is the process used in today's nuclear power plants, fusion does not produce dangerous radioactive waste or carry the risk of catastrophic accidents. It also uses fuels that are abundant in nature. The most common fuel for fusion is hydrogen, which can be extracted from water. This means that if we can make fusion work efficiently, we could have a nearly endless supply of clean energy. Scientists around the world are working together to make fusion a reality. Besides ITER, other major projects like the National Ignition Facility in the United States and the JET experiment in the United Kingdom are also making significant strides in fusion research. The largest of these efforts, ITER, is being built in France as a collaboration between multiple countries, aiming to prove that fusion can produce more energy than it consumes. ITER aims to prove that fusion can produce more energy than it consumes, which would be a huge step toward making fusion power plants possible. If scientists succeed, fusion could provide a future where energy is cheap, clean, and almost limitless. It could reduce our dependence on fossil fuels, slow down climate change, and power our world in ways we can only dream of today. Although there are still many challenges to overcome, researchers are making progress every year. One day, the same process that lights up the stars could light up our cities, forever changing the way we live.
Got a question about how something really works? Drop it in the comments and we might cover your topic in our next video.